Hey everyone, welcome to our next video. This one is going to be over 3.5. So let me head over to our notes and write down. So 3.5 is double angle and half angle identities. So I'm going to start off by just writing all the identities for you. Now a lot of these identities, let me label this. So first I'm going to do the double angle ones, and then over here I'll do the half angle ones. So I want to start off by telling you that these identities can be proven. That is something more that we would do in Math 240 for those of you who are moving on. I could do them now, but truthfully I'm just going to kind of focus on using the identities. So sine of 2x would be equal to 2 sine x times cosine x. So that's the sine double angle. Next we have the cosine double angle. This one has a few variations. So we've got cosine squared x minus sine squared x. You can also use 2 cosine squared x minus 1. You can also use 1 minus 2 sine squared x. So you've got some options for that one. The tangent double angle looks like this. So that's all the double angle identities. Next I'm going to write my half angles. So the half angles, sine x over 2 is equal to plus or minus square root 1 minus cosine x over 2. Then we've got cosine x over 2 is 1 plus cosine x over 2 in the square root. And then tangent half angle actually has some options as well. So I'm going to write those 3 for you. Now, which one you would choose really just depends on the situation. It depends on what you're trying to accomplish. So those are all of your identities, and these are all written on the identity sheet that you'll be given on test 2. So you don't actually have to memorize these or anything like that, by no means. You just have to know how to work with them. So let me show you some examples of how we can work with these different problems. For my first one, I actually want to do a verifying problem. So we're going to verify cosine 2x minus cosine 2y divided by cosine x minus cosine y. And I want us to show that this is equal to 2 cosine x plus 2 cosine y. So first we're going to start with our left-hand side. So I have cosine 2x minus cosine 2y divided by cosine x minus cosine y. So I just want to show you one way to kind of replace things with the identities. This is just one option of using them. So right now my issue, think about where I'm trying to get to. My issue is that I'm trying to get to my right-hand side, and that one does not have 2x and 2y, it just has x and y. So I want to replace these. And so for that, I'll look at my cosine double angle, and I can pick one of the three. Now, which one you would pick just depends on where you're trying to get to. Something I notice is that we don't seem like we want sine at all, because I'm trying to get to stuff that only has cosine in it. So I'm going to pick the one that only has cosine in it. So I'm going to use this identity to help me out. So it says cosine 2x is equal to 2 cosine squared x minus 1. So when I replace these, so cosine 2x is going to become 2 cosine squared x minus 1. And then cosine 2y is going to become, be careful here, you want to keep parentheses because we have that minus in the front. This will become cosine, let me rewrite, 2 cosine squared y minus 1. And so I applied it to this identity. It's just instead of seeing an x, I saw a y. And this is all over cosine x minus cosine y. Next, I'm going to simplify. So I get 2 cosine squared x minus 1 minus 2 cosine squared y plus 1. And this is divided by cosine x minus cosine y. So there I just simplified. I see that I can simplify more because I have this minus 1 plus 1, so that goes away. So now I have 2 cosine squared x minus 2 cosine squared y divided by cosine x minus cosine y. Now I'm hoping maybe you can start thinking about canceling out. However, we have to be really careful here. We can't cancel out unless it's like split up by multiplication. What I mean by that is right now in our numerator, we have that minus. Sorry, I yawned. And I was like talking while I was yawning. You can't like use division to undo subtraction. So we actually need to do some factoring first. So the first thing I'm going to do is factor out a 2 just to get it moved out of the way. So I have 2, and then I'm going to be left with cosine squared x minus cosine squared y. And this is divided by cosine x minus cosine y. I also know that I can't just like cancel out. Like I think that would be the temptation, right? Is just to say, okay, these cancel each other out. But then I'm still left with this minus here, and I'm supposed to end up with a plus at the end. So that definitely would not be the way to go. So don't do that. It's very bad. What we can do, however, is we can factor. So in this parentheses here, I'm going to switch over to brackets. And so I actually have a difference of squares happening. So remember, like on the side over here, all right? So if you have like x squared minus 4, this factors into x minus 2, x plus 2. That's what we're going to do here. So this would become cosine x minus cosine y times cosine x plus cosine y. So what I did there is I factored. This is still divided by cosine x minus cosine y. Now that everything is split up with multiplication, now I can cancel. So these can cancel out. I can distribute that 2 back in. So I get 2 cosine x plus 2 cosine y, which equals my right-hand side, so I'm done. So this was just an example of using the identities to help you like simplify or verify. Next, I want to do some that are similar to problems we did in 3.3, 3.4. So these say use the half angle identity to find the exact value of cosine pi over 8. Now, just a little bit of a disclaimer. On the test, I'm not going to tell you which identity to use. So for something like this, I would usually recommend, if it was cosine and you're trying to find exact value, I probably would prefer using the sum or the difference identity over using the cosine half angle identity. But I still want to show you how to use it, so I'm going to rewrite the identity first, just so that we have it here to take a glance at. And so we're trying to apply our problem to this. So what we're saying is, okay, let's start with cosine pi over 8, and we're going to say that this is equal to cosine x over 2, which is equal to plus or minus 1 plus cosine x over 2. So this is how I'm using the identity. But what we want is like an x value to use. So first I need to figure out what that needs to be. So what we want to think about is what angle could I divide by 2 so that I get to pi over 8. If you want to, you can actually set it up a little bit like an equation. If I multiply both sides by 2, I get 2 pi over 8, which simplifies to pi over 4. Now this is a good sign because we just got an x value that we know a lot about, right? Like I know a lot about cosine at pi over 4, so that's why it's going to help me out. So then on the other side of my identity, I'll now have 1 plus cosine pi over 4, and then divided by 2. So this I can simplify. So I get plus or minus the square root. Cosine of pi over 4 is root 2 over 2, and then this is all over 2. So I'm simplifying. I get plus or minus square root. Remember that when you divide, that's the same as multiplying by the reciprocal. So instead of dividing by 2, I can multiply by 1/2. This will give me 1/2 plus square root 2 over 2. I'm sorry, square root 2 over 4, sorry. Then I need to combine these fractions, so I can multiply this by 2 over 2. So this gives me plus or minus square root 2 over 4 plus root 2 over 4, which becomes 2 plus root 2 all over 4. I can simplify that denominator by taking it out of the root, and it becomes a 2. Now we're almost done, not quite, because I need to figure out, should it be plus or should it be minus? Now pi over 8 is going to be in quadrant 1. Part of the reason I know that is because if I get to pi over 8 by doing pi over 4 divided by 2, that means it's smaller than pi over 4. So it's going to end up in quadrant 1. And cosine is positive in quadrant 1. So positive in quadrant 1. So that's why this becomes a positive root 2 plus root 2 over 2. And that is going to be my final answer for this one. Now, what I would personally do if I just saw this problem out of nowhere is I would probably prefer to use the cosine addition or subtraction identity. So what I would say is, if you made this in degrees, let's find out what that would be. So this would be 22.5 degrees. That might be a little hard to use the sum and difference identities with in its current form. So let's see, maybe it'd be easier to keep it in radians. So if I took pi over 8, and let's see, I took pi over 3, pi over 4, pi over 6, maybe pi over 2. And what if I try to use these a little bit? So pi over 4, I can get to be 2 pi over 8. Pi over 2, I would get to be 4 pi over 8. I can't really add or subtract these, so I guess maybe this would be a good one to just use the half angle identity. But I'm glad I showed that, because sometimes you'll just kind of practice and you'll notice that certain identities are better. So I didn't even realize about this question. My natural instinct is to try to use a sum and difference identity. But I really do like that you can see that since you get a decimal here, it's really hard to think of two angles that would add or subtract to get there. But you can divide to get there. So actually, the half angle is pretty useful for this one. But let's say I use something like this. So if I say use half angle identity to find exact value for sine of 75, this one I would not use a half angle identity, because it's super easy to think of two things that could add or subtract to get to 75. I could easily use 30 and 45 for this one. But using the half angle could be helpful sometimes, like for example 2. So it just depends. But let's go ahead and do this one just so we can practice using the identity. So sine x over 2 is equal to plus or minus 1 minus cosine x over 2. So there's the identity. So I'm trying to compare it to sine of 75. So I have sine of 75 degrees is equal to sine x over 2, which would be equal to the other side of the identity, which is what I actually want to use, but I need to know my x value. So to find my x, I need to find out what would I divide by 2 to get 75. So I like to set it up as an equation, and I get 150. So my x should be 150. So I'm going to write that in. So I get, I'm trying to color code a little bit. So I get sine be 150 divided by 2 is equal to plus or minus the square root 1 minus cosine 150. And so again, the reason that we are doing this is because now we have an x value that we can actually work with. 150 has a reference angle of, I'm pausing so maybe you can think about it, 30 degrees. So I know cosine of 30, so I can know cosine of 150. So here I get plus or minus 1 minus. Now cosine 150 would be the same as cosine 30, but we do have to be careful because it's in quadrant 2. Cosine is negative in quadrant 2. And it'll be root 3 over 2, and then I get over 2. So I'm simplifying now. I get plus or minus. This would be 1 plus root 3 over 2 times a half. I get plus or minus square root 1/2 plus root 3 over 4. This becomes 2 over 4 plus root 3 over 4, which will be 2 plus root 3 over 4. I can simplify the bottom, so I get 2 plus root 3 over 2. Now we got to be careful. I need to know if this on the outside should be a plus or a minus, and that's based on the original angle. So the original angle was 75, that's in quadrant 1. Sine is positive in quadrant 1, so it's going to be a positive on the outside. So the plus or minus on the outside is dependent on where like the original angle is. So just be careful there. But again, I just want to remind you with this one that if I was like doing this one just on a test or something, I'm not going to tell you which identity to use. So I would probably have used the sum and difference, which we actually did this one with sum and difference, I believe, or something really similar. So it just depends. Now, one that I do like to use it for is tangent. So this one, we're going to use the half angle. Identity to find exact value tangent negative 15 degrees. And the reason that I want to do this one is because we actually did this one in a previous video. So if I scroll up real quick, we did this one right here, but we used the like sum and difference identities. And it was kind of hard, like, to simplify. So we had to use like the conjugate, and we had to deal with all these fractions and stuff like that. And so I just want to show you with the half angle identity, it's actually a lot easier. So first, we have to choose which half angle we want to use, because with tangent you have these 3 options. So we can either use 1, 2, or 3. I'm going to tell you that for this type of problem specifically, this third one is going to be the easiest to simplify. So that's the one that I'm going to work with. But different identities, will be used in different like scenarios. It just depends on what you're given and what you're trying to do, you know? So it just depends. But for this type of problem, like just finding exact value at like a certain angle, I would definitely say that that third one is going to be easiest to simplify. So let's do it. So I come down here and I'm going to rewrite the identity for us. So tangent x over 2 is equal to 1 minus cosine x over sine x. I also see that I have a negative on the outside. So there's some options with that negative. Either we can add 360 to 15 to make to find the coterminal angle. The issue with that is then when we find our x value, it's going to be really big. So it might be hard to do it that way. You can try it out and you'll probably see what I'm talking about. The other option though is that we can use the fact that tangent is an odd function and we can move that negative out to the front. So in this case, I'm going to start off with negative tangent 15 degrees. And so what that's going to do is it's going to make me just like carry the negative with the identity. So now I have negative tangent x over 2 would be equal to negative 1 minus cosine x over sine x. So because of that negative, which is going to hang out with us on the outside up until the very end when I simplify. Now I got to find my x. So you want to think, what do I divide by 2 to get to 15? So of course, I recommend you kind of just thinking about that, pausing it, maybe even try to work this one out on your own. But we will get that the x is 30 degrees. So I'm going to rewrite what I've got. So I have negative tangent. And now instead of x, I'm going to have 30. And now it's just a matter of simplifying. So cosine of 30 is square root 3 over 2. Sine of 30 is 1 over 2. Now remember that dividing is the same as multiplying by the reciprocal. So instead of dividing by 1/2, I can just multiply by 2. This equals negative, on the outside still, 2 minus root 3. And now at the very end, I'll go ahead and distribute out that negative. So I get negative 2 plus root 3. Now, in my opinion, that was way easier to simplify than when we did it in section 3.4. So when it comes to like exact value of tangent, I love to use the half angle identities. I think they are super helpful when it comes to this type of problem. I would definitely choose this over using like a sum and difference. Now there are some other types of problems that I just kind of want to show you. So let's do this one. It's another, just different types. This says, given cosine 2 alpha is equal to 2 over 3. And it says that 2 alpha is between 0 and 90 degrees. Determine the exact values of sine alpha. I think I did that earlier too. Sine alpha, cosine alpha, tangent alpha, cosecant, secant, and also cotangent. So we're going to have to find all of these. So this is an interesting one. So for this one, because you see 2 alpha, it might be tempting to try to use one of the double angle identities. However, with this one, you're actually going to use the half angle because you're trying to get rid of the 2. Like you're trying to go from 2 alpha to just alpha. So if I use my identities for a second, I'm going to write them out for us. So we've got cosine x over 2 is equal to plus or minus the square root 1 plus cosine x over 2. I also have the identity sine x over 2 is equal to plus or minus the square root 1 minus cosine x over 2. So I'm just going to start off with those. If I let x equal 2 alpha, I want you to see what happens. I get cosine 2 alpha over 2 is equal to plus or minus the square root 1 plus cosine 2 alpha over 2. And I could do the same thing in the sine identity as well. But what this will do is it'll give me cosine of alpha. So then I have plus or minus 1 plus. Now I know cosine of 2 alpha because they gave that to me. That's what they said was 2 over 3. So I can replace it with 2 over 3. So then I have cosine alpha is equal to plus or minus. Now I'm going to have to simplify this. So I have square root 1 plus 2 over 3. And I'm going to multiply this by 1/2 instead of dividing by 2 because I'm using the reciprocal. This becomes plus or minus 1/2 plus 2 over 6. Sorry, make sure I distribute that properly. Then I can combine these fractions, so I get plus or minus. This would be, I can write it as 3 over 6 plus 2 over 6. So I get plus or minus 5 over 6. Now I have to decide, should it be plus or minus? So if 2 alpha was between 0 and 90, if I divide all this by 2, I get that alpha should be between 0 and 45, which would also put it in quadrant 1. So it just stayed in quadrant 1. And cosine is going to be positive in quadrant 1. So this becomes square root 5 over 6. My math lab is usually, and also Alex, depending on what we're using at the time of watching this video, they can be kind of sticklers about simplifying fractions. So this fully simplified would be root 5 over root 6. You'd have to multiply by root 6, so it'd become root 5 times root 6 over 6, which simplifies to square root of 30 over 6. So this is cosine of alpha. Now there's multiple ways to get the rest of it. So you definitely have some options at this point. Either you could use the sign identity and do it exactly how we just did it. Me personally, I would probably say let's just use triangles. So cosine of alpha is giving me the adjacent over the hypotenuse. So I would just make it into a triangle and say, okay, it's in quadrant 1. So the adjacent side would be root 30. The hypotenuse is 6. Let me go find this other side. I'll just call it A. And I would use Pythagorean theorem. So this would be a squared plus root 30 squared is equal to 6 squared. So this would give me a squared plus 30 equals 36. So then I get a squared equals 6. If I subtract that 30, so a equals square root of 6. And so that's my opposite side. So now I can go get everything. So sine of alpha would be opposite over hypotenuse, so root 6 over 6. And then I already had cosine of alpha. I needed tangent. Tangent would have to be opposite over adjacent, so that would be root 6 over root 30. Be careful here, they're going to want you to simplify. Simplified would be times square root 30 over square root 30. And this can break up. So let's see. Right now I'm just doing some algebra. So this would be over 30. 6 can break up into 2 and 3. 30 can break up into 3 and 10. So a 3 can actually pull out to the front. So this would be 3 square root 20 over 30, which actually becomes square root 20 over 10. Is that fully simplified answer? And I don't believe it can, actually, yeah, it actually can reduce even further. Let's keep going. So reduced even further, square root 20 is 2 times 2 times 5 over 10. So now a 2 can come out to the front. So actually this reduces to square root of 5 over 5. And I don't think we're going to get any simpler than that. And then you could do the rest of them as well and just kind of check it out. You just have to be careful when you're plugging it into like the online homework that it is fully simplified. Let's do the other ones together. So cosecant of alpha is hypotenuse over opposite. So that's going to be 6 over root 6. That simplifies to 6 root 6 over 6. So that'll be just root 6. Secant is the hypotenuse over the adjacent, so 6 over root 30, which will simplify. I'm going to simplify this one fully for us as well. So let's see, 6 over 30 can reduce by 2, nope, by 6, oh my gosh. So I get root 30 over 5. Can root 30 simplify at all? I gotta think. No. So that's going to be fully simplified. Because it would be 3 times 10, and 10 is 2 and 5, so I don't have any pairs. That's always what I'm looking for. And then lastly, with cotangent, it would be the adjacent over the opposite. So root 30 over root 6. The simplifying on these is crazy. So you get root 30 times root 6 over 6. And this can reduce a good bit. So let's see. Root 30 becomes 3 times 2 times 5. 6 becomes 2 and 3. So I can pull out a 2 and a 3. So this will become square root 5. Wow. That was a lot to simplify. A little bit of a disclaimer for the test. I do not make you simplify all of those down as far as the online homework is going to make you do. I also think that this problem took a while. So realistically, I don't think I could ask you for all 6 of the trig functions. I might just ask you, like, find cosine alpha given cosine 2 alpha. You know, like, just make you do, like, that first part that we did. I think would be more, like, realistic for a test. That one was kind of brutal to simplify, honestly. But I'm glad that I show it to you because it's just good to practice. Let's do another one kind of similar to this where like they give you one function and you have to like go get a different one. So example 6. This one says find the exact value of sine 2 theta given that sine of theta is equal to negative 35 over 37 and theta is in quadrant 4. All right. So now we're looking for sine 2 theta. So if that's what we're looking for, first I would come up with that identity. So sine 2 theta, this is one of the double angles. It says 2 sine theta times cosine theta. So I already have sine theta, which is really great. So I can just plug that in. So negative 35 over 37. But I don't have cosine theta. But we can go get it. I would use triangles to do it. So sine theta, it says that it's in quadrant 4. So I'm going to go look in our quadrant 4. And remember that theta. So remember that sine is opposite over hypotenuse. So it would be negative 35, and this would be 37. I can go get this side that's missing, and that'll help me find cosine of theta. So this is just one option of using the triangle. You could also use identities to do it. So we also have the identity that sine squared theta plus cosine squared theta is equal to 1. So I could plug it in this way as well and do negative 35 over 37 squared plus cosine squared theta equals 1. And I could find cosine of theta this way. I'm going to do the identity version just to give you some variation through this section of how you can do things. So this would be, I usually try to give you smaller numbers to work with because I try to structure the test to be no calculator. So let's see, this gives me 1225 over, I mean, I would not expect you to have to do numbers this large and square them. So then I'll subtract that fraction over by the other side, which is going to give me 1369 over 1369 minus 1225 over 1369. I want to do this with fractions as much as possible so that I don't have to reduce as much. Well, I can reduce like better is what I'm saying, because I'm pretty sure the homework, the online homeworks, they almost never want you to use decimals. Sometimes, but that's really the exception. I don't ever want you to use them, but I usually make the work a bit easier. If I take the square root of this, I'm going to get cosine theta is equal to 12 over 37. Now I got to be careful here because it's in quadrant 4, so we have to think, should cosine be positive or negative in quadrant 4, and it'll have to be positive. So then I would go plug this in over here. And then it's just a matter of simplifying. So again, I try to give you better numbers than this. I just want to be really clear about that. But your final answer I'm just multiplying that top would be 840 over 37. And then we always want to check, can this reduce at all? Sorry, I'm a little silent. I'm just, working through the problem, making sure that I've done everything correctly. Trying to check my work. See if there was anything that I made a mistake on. I believe I did somewhere. I believe I did. So let me try to figure out where that is. Okay. This is one of the ones from the online homework. So I tried typing it in, but oh my gosh, this is so funny. Such a silly little mistake. So whenever you add and subtract fractions, you keep the denominator the same. We need to multiply our denominator in this case. I was keeping it the same because I was just thinking of adding and subtracting. That makes sense. So be careful. Sometimes these things just happen. There we go. And let me go ahead and type this in. Hopefully it's reduced. Just some things to watch out for as you do these problems. Yeah, that was the right answer. I'm glad it was just an algebra issue at the end and not like a trig issue, But just be careful. It happens. But sorry for being so quiet on it. I was just trying to figure out what I did. All right, so let me just think if there's any more. I'm kind of looking through the homework a little bit just to see if there's any more that maybe I really should do. making sure that I've hit every kind of like type of question and stuff like that. There's some slightly easier ones like this one. Let me show you one more. This one's not too bad though. This one says to simplify 2 cosine squared 15 degrees minus 1. So this one, it's looking like it's giving you like one of the other sides of the identity. So if I come up here, back up to my identities, and you'll have an identity sheet, it looks a lot like this identity right here. So if I use that to my advantage, I'm going to write down the identity first. So it says cosine 2x is equal to 2 cosine squared x minus 1. So in this case, it's looking like 15 is my x value. So I would get cosine 2 times 15, which is cosine of 30, which is square root 3 over 2. So that's like a pretty nice one. So sometimes you'll have to use the identities in that way, like going from the longer version to the shorter version, like going from the right side to the left side. So it just depends, but I think that was pretty good. I really did show you almost every kind that's on here. Some of the ones that I did show you today, I would say are a little bit harder than what I plan on testing you with. Some of them are right on par though. So I would definitely say that if you can do these problems and if you can do the ones on the online homework, then you will be in good shape for the questions on the test. So just one more time, you do have an identity sheet. All the identities that I put at the top will be on that sheet, so you do not need to remember any of them. And I have posted that on Canvas, so you're welcome to go and look at it. Maybe print it out and start using it for while you're doing your homework. Because remember that while you're doing the homework, you don't have, like, if you look at the notes while you do it, you're kind of hurting yourself for the test. But you're given the identity sheet, so that would be good to have, like, next to you, because it'll mimic the test, you know. If you are having any trouble or anything like that through these sections, please don't hesitate to reach out to me. This is actually it for us for Chapter 3 as well, so our next video will be over starting Chapter 4. So altogether, I hope y'all have a wonderful day, and I will see you in our next